Hi everyone. So this is in continuation of the earlier video where we were discussing about the exam syllabus. Okay. So next is this programming and data structure, important part, very important part. Example programming in C. They will give you questions on pointer and structure and all, especially in scientist B. Those will not be of much difficulty, but the representation will be such that you will think like it's a very difficult question. So you have to take care that you have to have a general knowledge, specifically like how to find an prime number, how to find a palindrome in a CS in a C language program, how to have an inversion or a transpose of a matrix. Such kind of thing only will be there, but that will be implemented through pointers and all, and it will be difficult for you. Functions an important part, especially they will ask recursive kind of programs. Okay, recursion is specifically mentioned. Parameter passing, scope binding, you can leave this. Arrays, stacks, queues, specifically they will not ask linked lists to, and but that will be a part of a program in C. Okay. Trees and binary search trees, BSTs, binary heaps are important. So you go through max binary heap, BST, and B tree, B plus tree. So what's the difference between those, and which one is better? What is the time complexity of searching in B tree, for example, n log n, and for example, what kind of what does in heap max if function does, and all such kind of things can come. And I will be going to cover this important questions that will be more or less straight away one word answer, so not much is needed. Important OOPS concept like object, class, inheritance, polymorphism, abstraction, encapsulation, these all are important, but much not is expected from there. Straight away definition can come, but not much expected. Algorithm is an important subject, specifically asymptotic analysis, best worst average case analysis. Please, I have given some sorting algorithms, analysis, and time complexity of those, so you go through it. And similarly, NP hard, NP complete. So which all problems have been classified under which, like TSP, traveling salesman problem, finding a click, and such kind of where it gets classified, you go through it. You have to have knowledge of greedy approach, dynamic approach, divide and conquer. For example, merge sort for and quick sort comes under divide and conquer. Greedy approach, knapsack problem, dynamic programming, flight virtual algorithm, tree and graph traversals is an important point. Okay, so you go through it, and finding out what's the difference between tight upper bond and loose upper bond, loose lower bond, and all. Best which one is used to represent best case complexity and worst case complexity. So similarly, these are important topics, so you go through it. Okay, and I will also be covering important questions of this, and try to give some of what best I can tell you in terms of theory of computation. You can simply go through what's the DFA, context free grammar, context sensitive grammar, Turing machine, and under which operations they are okay. For example, whether they support complementation, whether they support augmentation, and all those things. Specifically one question comes to they ask, and similarly they will give you one particular automata, and then you see which language it accepts, or you have to find one grammar is given which languages accepts. So such kind of question will be there. And similarly you go through recursive and recursively enumerable and such kind of problems. Okay, and meanwhile next is compiler design. So next is compiler design. In compiler design, you just go through some of important points like lexical analysis, and DAG representation, and type of parsing like bottom reduce parsing, top down parsing, and all. Okay, and S- Cost benefits analysis, if we do, you can skip this compiler design. It's the most typical part, and but at most one or two question is expected here, so you can leave this one. Operating system is a must thing, and specifically like processes, threads, inter-process communication, not much expected, but deadlock is important thing. Banker's algorithm, synchronization is important, like P and V based synchronization process, and deadlock, what are important characteristics, like mutual exclusion, hold and wait, circular, and all those things. Similarly, CPU scheduling is very important point, like FCFS, shortest job remaining, SRTF, shortest remaining time first, priority scheduling and all. Memory management is also important point, specifically paging and segmentation, and questions can come on the basis of page table, TLB and all. Virtual memory is an important concept, which can be used for finding out tag and all questions. File systems is important, specifically if I have to find it out, how many how many tracks or cylinders you have to travel, finding a specific content using elevator method, using first come first serve method, and so prior production and security, not much expected, so leave this important topics. Okay, these are some of the important topics. Database, you have to know first normal form, second normal form, third normal form, BCNF form, which one is the most tightest among them. Relational model, some SQL queries and relational algebra, such kind of question can come, and you have to be aware of whether one is representing which one. Okay, group by and having is an important SQL query, which is you should be aware of. Similarly, B and B plus T and a comparison with the BST. Okay, relational algebra tuple, I already said so. Transaction concurrency control is an important, and you should know important properties like acid property, atomicity, consistency, isolation, durability. Concurrency control में serializability and conflict serializability, those kind of questions are important. Okay, next is software engineering. Okay, so in software engineering you should have a basic knowledge of various life cycles, like waterfall model and prototype model, evolutionary model, spiral model, those kind of models. Similarly, data flow diagrams, ER diagrams, and relationship diagrams, and coding, testing, implementation, maintenance, important phases of special. One question is, what is an important specification of SRS, system requirement specification document, and one important thing is it doesn't have algorithm or important code snippets of the whole program. Okay, so that's the important thing. Similarly, Kokomo model and cyclometric complexity, and important formula of that V minus E is V minus E plus F is equal to 2 for finding of number of bounded phases and all. So those are important for from software engineering perspective, and more or less practicing some old paper will be sufficient for tackling it. Computer networks is an important topic, where you can get the maximum cost benefit analysis, like IPv4, IPv6. In IPv4, routing happens through which routers on the basis of IPv4 addresses, like class A, class B, class C addresses, and ISO OSI stack is important, which layer support which kind of work, like what is important about application layer, session layer, and presentation layer, transport, internet, data, DLL layer, and physical layer. So such kind of thing is need to be. Flow and error control is important property of DLL and TCP, so you have to go through it. Similarly, these are important protocols: ICMP, Internet Content Master Protocol of IP layer, DNS, domain name server application, SMTP application, POP application, which is used for downloading content from mail server to your point. FTP, file transfer protocol, which port number they use is important. HTTP, hypertext transfer protocol, uses TCP underlying for transmitting information. Uh, so these are important questions, and you have to go basic knowledge of hub switches, gateways, and routers are important. I will go through it in detail, because I feel this is an important topics, and it can be a cost benefit analysis why it will be good for you people. And similarly, some important knowledge about public key and private key algorithms, like public key and private key RSA algorithm, and MD5 and all, from digital message digest point of view. Digital signature, what is digital signature? So these are important topics, and similarly firewalls and all, and cryptography, private key RSA and all, you can go through it. So which these are the one which are important. Apart from a previous gate paper are very important, and those combination of those will be I will be covering. I understand that for other branches it is quite difficult to make it, but I make you believe that if you can handle first 60, can make you at least score 30 question if you go through some of these topics in details, and that will not going to cover much time also. So that's from me, and I'm going to come back with some specifically topic wise questions and important topics, and detailed help will be available to one who has subscribed to my test series and all. And apart from his test series, papers are also there. So I believe that will be good. And so that's all for today, and thanks, and keep working.